Okay, welcome back to this session where we will be going through redox. Okay, so we have introduced the definitions of redox yesterday. We have done the definitions of redox in terms of oxygen, hydrogen, and then we ended off with this page, page 4, which is in terms of electrons, right? Now, why is there a need for so many different definitions? So as explained yesterday, not every single reaction has oxygen inside. Not all reactions have hydrogen inside. So quite clearly, the first two definitions of redox are more restrictive because they just will not be able to be applied to many reactions. The majority of reactions don't have oxygen or hydrogen, okay? But we know that, well, in a chemical reaction, electrons are commonly lost or gained. So this definition of electron loss and gain is indeed very applicable, okay? So we learned yesterday, oxidation is loss, reduction is gain of electrons. So this acronym, oil rig, is an important acronym to learn. Now, how can you tell from a half equation if something loses electrons? Well, if you look at the half equation, the position of the electrons tells you that. So if you scroll, okay, this is what we went through yesterday. The half equation, if the electrons appear on the right-hand side, this means that the substance has lost electrons. It has produced electrons, right? Set it free. Whereas, if the electrons are on the left-hand side of the half equation, this means that the electrons are gained. Okay? So the position of the electrons in the half equation tells you whether it's electron lost or electron gained. Okay? And we also spoke briefly about which types of elements are losing electrons. So for example, metals lose electrons, right? So metals will be easily oxidized because oxidation is loss of electrons. Whereas non-metals, they gain electrons. Therefore, non-metals are easily reduced. Okay? So we also stopped at a few questions. Okay, so as mentioned, this is like a typical exam question. The question in the exam will specify which definition of redox that you should use. So you just need to ensure that you follow the instructions within an exam question. Okay, so like in this case, they are just asking you for the underlying substance, whether it's reduced or oxidized, in terms of electrons, meaning you must use electrons to answer the question. Now you can see that, okay, in part A, Cu is oxidized as it lost electrons to form Cu2 plus. Okay, for part B, Cu2 plus is reduced because it gained electrons to form Cu. All right, and I also told you to try the remainder of the questions yourself so that you can practice seeing half equations and seeing whether you can recognize if the electrons are lost or gained. So I would advise you to actually try these questions yourself slowly over the holidays. Now, we also went on to question set 2. Now, question set 2 is not half equations, it's ionic equations, right? So you can see that there are ions there, like Ag plus, Cu2 plus, these are ions, these are ionic equations. How can you tell from an ionic equation if something lost electron or gained electron? Well, the charge says a lot. If it goes from Ag plus to Ag, it becomes less positive, right? At first, there's a 1 plus charge. At the end, there's no more charge. So it became less positive. Less positive means it gained electrons. And that's why we say that Ag plus is reduced because it gained electrons to form Ag. So on the other hand, Cu is oxidized. How do I know that? I look at the charge. Cu at first no charge. The metal has no charge, but at the end is Cu2 plus. So it became more positive. If you become more positive, you must have lost electrons. Okay? So my next question is, so do all reactions contain ions? Think of the reactions that you have learned. Do all reactions really have ions? Well, I'm sure you know by now, ions are present if the substance is an ionic compound, right? For example. But the type of bonding in compounds, is it always ionic? So what do you think? Is the bonding always ionic in a compound? Well, answer is obviously no, right? You spend a very long period in term 2 learning different types of bonding. You know that metal plus non-metal forms ionic compound, got ions. But equally, besides ionic bonding, there are other types of bonding, such as covalent bonding. Covalent bonding is where non-metals share valence electrons with each other, right? So in a covalent molecule, there are no charges, there are no ions to talk about. So does it mean that if it's a covalent molecule, it will not undergo redox reactions? Well, that's not true, right? Okay, if you think back, I mentioned things like oxidation includes things like combustion. Combustion is just burning, right? You could burn covalent substances. For example, you burn fossil fuels. Fossil fuels are covalent molecules, you know. So clearly, it need not be ionic. Covalent molecules can also undergo redox. Then how? This definition of electrons loose, electrons gained will not be applicable, why? Because covalent molecules, they share, right? And that's the reason why we now need the last definition for redox. And the last definition for redox is the most applicable because it can be applied to every single type of redox reaction. Okay, so now we're going to move on to the final definition for redox, which is in terms of oxidation states. And this is applicable to all types of redox reactions. So let's turn to the next page. So what is oxidation state all about? Well, oxidation state, the first thing you need to know is not something that you can see. It's not something you can measure. It is not like temperature, you can put a thermometer in and measure 60 degrees Celsius. Oxidation state doesn't work that way. Oxidation state is actually a concept that was invented by scientists to help us understand reactions better. So it's really a concept that's invented. It's not something physical that you can measure. Of course, there are ways to get more information about oxidation states through experiments, but it's not something that you can use a ruler or thermometer to measure. So what is oxidation state? Now, oxidation state is the charge that an atom would have if it existed as an ion. But importantly, we already said not everything is ionic. Not everything is an ion. So this is really the charge that we imagine that it would have, even if it's covalent. That means I can assign oxidation states to specific atoms in a covalent molecule. Okay? Get it? So it's a charge. The concept is charge. But we know that charge may not exist in a covalent molecule. But we imagine that it's there. Now, why is this so powerful? Because by imagining the charge, we can now see the changes in the charges, the oxidation states, and therefore we can work out what is reduced and what is oxidized. Okay? Now, the way to do this is that you need to follow the rules for assigning oxidation states. Briefly speaking, there are 3 rules. If you look at a textbook, there might be more rules, but I've summarized it into 3. Okay? Now, the first rule is the most important rule, which is the oxidation state of an element is 0. Now, what do I mean by element? Element means it's on its own. It is not combined with other elements. Now, how can you tell from a chemical formula that it's an element? Well, if you look at chemical formula like F2, well, F2 contains only fluorine, right? It contains only fluorine atoms. It is not combined with other types of elements. So we know that F2 is an element. So automatically the oxidation state of fluorine in F2 is 0. So let's write this down. The oxidation state of fluorine is 0 in F2. I want you to pay attention to how I have phrased it. Oxidation state of the element name. Okay, name, so I must spell, name the element, fluorine. The oxidation state of fluorine is what? The number 0. In the element is called F2. Okay, the substance formula is F2. Okay, so this is a fixed phrase. The oxidation state of an element is 0 in F2. Okay, so you name the element, then you give the formula. Okay. Now, this of course also applies to the other elements in the list. Okay, it applies to oxygen, O2. The oxidation state of oxygen is 0 in O2. Okay, so you could equally do this, the oxidation state of oxygen is 0 in O2. So you can see again, I have spelled the name of the element out. I've written number, what is the oxidation state is, and I've written the formula of the substance. Okay, so that's rule number 1. Rule number 2. Now, rule number 2 is an important rule. The oxidation states of certain elements in their compounds are fixed. Now, this is a very important part already. Compound means what? Compound means you got 2 or more elements chemically combined together. For example, sodium chloride, NaCl compound. Water, H2O, hydrogen, oxygen combined together chemically to form water compound. Okay. So this is a very important part. You need to be familiar with what's element, what's compound. So we are saying that certain elements, when they form compounds, the oxidation state is always fixed. For example, a good example is sodium. Sodium is in group 1. You have already learned group 1 elements like sodium have 1 valence electron. So they will lose 1 valence electron to form Na+. Right? So you go back to oxidation state. Oxidation state is the charge, meaning sodium, the charge will always be plus. Similarly, magnesium is in group 2. It will lose 2 valence electrons to form Mg2+. So the charge is always 2+, which is to say, the oxidation state will always be +1 for sodium, +2 for magnesium. Because sodium is group 1, it will always be +1. Magnesium, group 2, +2, the oxidation state. Okay, so I give you an example. Let's say if I have NaCl. I know Na is group 1. So we'll say that the oxidation state of sodium is +1 in NaCl. So you can see again, I have named the element sodium, but I've said that it's +1. It's no longer 0 because it's combined with chlorine, right? In a compound, okay, sodium is +1 oxidation state. And you must give the formula of the compound. Now, I'm sure you realize by now, oh, this looks a bit confusing. Why is it that we write Mg2+, but the oxidation state is +2? Now, this is a habit. It's a convention, right? Oxidation states are written with the sign first. That means whether it's plus or minus, the oxidation state are written with the sign first. So the oxidation state of magnesium is +2, okay, in a compound. whereas charge is written as 2 plus. So you just need to adopt the conventions used. Okay, so group 1 elements always +1 oxidation state in their compounds. Group 2 elements always +2 in their compounds. And the reason is because they always form these charges when they react. Okay. Now, another useful set of elements to learn is hydrogen and oxygen. Hydrogen's oxidation state will always be +1 in its compound. Okay? I'm not talking about H2. H2 is an element. I'm talking about hydrogen in the compound. So hydrogen will always be +1 oxidation state in its compound. Similarly, oxygen will always be -2 in its compound. So I'm not talking about O2. O2 is an element. I'm talking about oxygen as part of a compound. Okay. Now these are rules to be learned. Okay, hydrogen +1, oxidation, oxygen -2. Okay, in its compound. Now there are some exceptions, of course. I've written the exceptions there. Hydrides, for example, the oxidation state is -1. Peroxides, the oxidation state of oxygen in peroxides is -1 as well. Okay, now whenever you learn chemistry, you learn rules and you learn exceptions. Which one should you learn first? Obviously, you should learn the rule first. The exceptions, you learn it after you have mastered the rules. Okay, so I wouldn't be overly bothered with the exceptions now. I would much rather you learn the rules first. The rules meaning hydrogen is +1, oxygen is -2 in the compound. Okay. So follow so far? Do we have any questions on rule 1 and rule 2 before I move to rule 3? Question time. Any questions? Okay, no questions. I'll move to rule 3. Yeah. Now, rule 3 is putting together rule 1 and rule 2. Okay. Now, rule 3 states that the sum of the oxidation states must be equal to the overall charge. What does it even mean? So, for example, if I give you something like Cl minus, Cl minus, the charge is minus, right? And there's only Cl, which means that the oxidation state of Cl, or oxidation state of chlorine in Cl minus is -1. It is the charge. Okay, so if I were to give you something different, let's say if I give you O2 minus, then what is the oxidation state on oxygen? Well, the oxidation state of oxygen is -2 in O2 minus, because the charge is 2 minus. So the oxidation state is -2. Okay, so that's the first example where the oxidation state is equals to the charge. Then you look at more complicated examples below. We have CuO. Now, CuO is a compound, obviously. There's copper, there's oxygen, right? So in a compound, you have learned that oxygen is always -2 in a compound. So if oxygen is -2, what must copper be? You know that CuO has no charge overall. That means the oxygen and the copper, the charges must have cancelled each other out, right? So if oxygen's oxidation state is -2, copper must be +2. Because +2 -2, you add together, becomes 0, no overall charge. Okay, so you can see rule 3 is basically putting rule 1, rule 2 together. Over here, you apply rule number 2, which is oxygen has an oxidation state of -2 in its compound. So oxygen is -2, copper must be +2 to balance it out. Okay, Now we move on to more complicated examples where you have these polyatomic ions like carbonates. Carbonate is CO3 2-, right? The one you learned and memorized. So what is the oxidation state of carbon in CO3 2-? If I want to look at carbon, what the oxidation state would be? How do I do that? Firstly, can you please correct a typo error? The typo error is here. Okay, carbon is +4. Okay, can you strike out +2 and put +4? Now, how did Mr. So get +4? This is what you need to learn. Oxygen is always -2 in a compound. So oxygen is -2, oxidation state. But you have 3 oxygens because it's CO3, right? So 3 oxygens. If each oxygen is -2, then the 3 of them together will have a total oxidation state of -6. How did I get -6? -6 is obtained by taking 3 times -2. So the important note is that you need to look at the formula. There are 3 oxygens, therefore 3 times -2. Okay? Can? Now, then how did I get +4 for carbon? Well, you got to think. 3 oxygen is -6. Carbon must be what? Is it +6? Most students think, oh, must balance out, right? Balance out. So it must be +6, but that's wrong. Because you need to look, does this carbonate have an overall charge? Just now, CuO got no overall charge, right? There's no charge overall. But carbonate is an ion with a charge of -2. The charge is outside, 2-. That means the carbon plus the 3 oxygen together must give you -2. So if the 3 oxygen is -6, what must carbon be? Carbon must be +4. Why +4? Because +4 added with -6 gives you -2. Okay? Now, obviously this, in the exam, we are not expecting you to write an explanation like this. We are not going to expect you to ask you to explain, but you need to be able to calculate this yourself. That means you need to be able to calculate that the oxidation state of carbon in CO3 2- is +4. Now, I would always teach my students to do this with some algebra. Now, if you have something complicated like carbonate, always let the unknown, the one that you want to find. So let's say I want to find carbon's oxidation state. I let carbon's oxidation state be X. All right. And then oxygen is always -2. There's 3 -2, right? 3 times -2. And then I must equal what? Equal to the charge, -2. X plus 3 times -2 equals -2. So X plus -6 equals to -2. X minus 6 equals to -2. So X is +4. Okay, so this is how we usually do it. So this is how you get the oxidation state of carbon in CO3 2- is, the oxidation state of carbon is +4 in CO3 2-. Okay, so you can take down this algebraic way of doing it. Basically, just letting the unknown that you want to find be X. Okay, oxygen is always -2. You got 3 oxygen, so it's 3 times -2. Okay, and make sure that you equate it to the overall charge outside. The overall charge in this case is -2. Okay, now once you have taken it down, can you please give me a thumbs up so that I know you have taken it down? Okay, and if you have questions to ask, this is the time to ask. So now you realize, like, wow, so you can even give carbon an oxidation state. Of course you can. Oxidation state is an imaginary concept. It's the charge that carbon would have in a carbonate ion. We are imagining that carbon forms C4 plus. Is it really C4 plus in reality? No, it's not. It's just an imaginary charge that we assign to carbon based on rules, of course, so that we can work out whether it's oxidized or reduced after a reaction ends. Okay, so you must understand that this is not a measurable, concept like temperature is. It's not a physical quantity either. It is a concept that's invented for us to understand redox. Okay, and because of this, you can see why this is very powerful, because you could even assign, okay, elements as part of a covalent substance an oxidation state. Even though it's not ionic, you can use this definition to apply to it. Okay, so this algebraic way of working will be important. So if you turn to the next page, there are many practice questions. Some look easier, some look harder, right? So you can see that once you get to the end, wow, P, Q, R, S, T, these are quite challenging, right? So the idea is we need to work through all these ourselves. Okay, now we're not going to work through all of them now. I want you to try A and B. Okay, I want you to try E and F, I and J first. Okay, A, B, E, F, I, J. Okay, I'm just going to give you about 3 minutes to work these things out. Okay, please start now. Okay, if you are stuck or lost, you can just type in the chat to me so that I know I can help you. Otherwise, okay, you can also unmute yourself to ask. So are we done with A, B, E, F, and I, J? Can you like give me a thumbs up so that I know you're done? Because I'll be getting people to give me the answer. Okay, so for those who are done, I presume you have done these 6. Okay, so let's just start. Okay, so start with N2. What's the oxidation state of nitrogen in N2? Okay, let's have... Okay, Rishi, tell me what's the oxidation state of nitrogen in N2?
0.
Why is it 0?
Cause
Cause
rule 1.
rule 1 states that
it's an element.
okay, N2 is an element, right? It's not combined with other elements. It's an element on its own. Therefore, the oxidation state is 0. And that's correct. Great. Next, can we have Zinkang? How about P4?
0.
Okay, 0 as well. Okay, you notice that P4 again is an element. Okay, there are only phosphorus atoms, right? So it's an element, so the oxidation state will also be 0. Okay, so now we say goodbye to the elements. Let's go to the compounds. Let's go to E and F. Let's start with E first. E is carbon monoxide. So what's the oxidation state of carbon in carbon monoxide? Okay, Wei Sheng. What's the oxidation state of carbon? Oh, +2. Okay, he typed in the chat to me. Yes, it's +2 because we already know that oxygen is -2. So carbon must be +2 in order to have no charge overall. Okay. Okay, next we have CO2. Wow. So from CO, we now go to CO2. What's the oxidation state of carbon in CO2? Okay, maybe Wanhua, what's the oxidation state of carbon in CO2? Wanhua, are you there? Okay, we'll skip Wanhua first. Okay, how about Estella? What is the oxidation state of carbon in CO2?
So can you repeat your question?
What's the oxidation state of carbon in CO2?
+4.
+4. So do you realize immediately it's not the same? CO and CO2 are just not the same thing. Okay, the oxidation states of carbon are different. Okay, why are they different? Because CO2 has 2 oxygen atoms. Each oxygen is -2. So 2 oxygen already makes -4. So carbon must be +4 oxidation state in CO2. Okay, then now we go on to Cu2O and CuO. Okay, let's ask. First one, Cu2O. What's the oxidation state of copper in Cu2O? Okay, Andre.
The oxidation state of copper is +1.
+1, is it?
Yep.
Okay, +1, good. Okay, why +1? Because oxygen is -2, right? If oxygen is -2, but you got 2 copper, 2 copper, right? So copper, each copper is +1. Then you got 2 copper is +2, balances out the -2. Okay, then last one. Okay, CuO. Tiha, what's the oxidation state of copper in CuO?
2 plus
2 plus or +2?
+2.
Okay, so remember, oxidation state sign comes first. Okay, so this is where my question time comes. You can see that again, these two compounds of copper, they don't have the same oxidation states for copper. So I is called copper 1 oxide. J is called copper 2 oxide. So if you recall, for copper, we had taught you that you need to write the Roman numeral copper 2 sulfate, copper 2 nitrate, copper 2 chloride, copper 2 carbonate. Why is it so important? It is because the transition metals like copper, these are metals in the center of the periodic table, right? Transition metals like copper, they can form compounds with variable oxidation states. Okay, copper has variable oxidation state in its compounds. So for example, when copper reacts with oxygen to form the oxide, you have two types of oxides, copper 1 oxide, copper 2 oxide. There are two different oxides with different oxidation states of copper. This is a property of transition metals. Okay, so the metals in the center of the periodic table, they will display this property where they form variable oxidation states in their compounds. So what does this 1 and 2 mean? So many students always confused. They thought that 1 and 2 means the number of copper. No, it's not number of copper, right? If you look at copper 1 oxide actually has 2 coppers inside, no? So the 1 and 2 has nothing to do with the number of copper. The 1 and 2 is the oxidation states. So this 1 and 2 refers to the oxidation state or the charge on the copper. Okay. So similarly, you have learned these Roman numerals for iron. Iron 2, iron 3. The 2 and the 3 refers to the oxidation state or the charge on iron. Okay. So let's take this down. This is important. Okay, so you have learned today, oh wow, transition metals, they actually can form variable oxidation states, different oxidation states in their compounds. And now you have learned the real meaning of the Roman numeral 1, 2, 3 refers to the oxidation state on that element, that metal in its compound. Okay, questions? Are there any questions at this point? Okay, good. Can I understand? Okay, can I have some response, please, from the audience? Okay, thank you, Arun. Okay, so now you know a little bit more. Okay, so you discover a little bit more day by day, you know, why we tell you that, oh, for copper compounds, you must write copper 2. Some of you at the start of QA, you didn't write the 2, right? You just wrote copper sulfate. Nope. You need to write copper 2 sulfate because copper also has copper 1. Okay. So same for iron. You need to write iron 2 or iron 3. And now you know what the numbers actually mean. Okay, now let's go to the more challenging one. Let's do M, N, and P. Okay, so I want you to work on M, N, and P. Now, why are they challenging? They are challenging because now you're going towards ions. These are polyatomic ions. Okay, they have charge overall because they are ions. I want you to now tell me what's the oxidation state of the underlined element in these 3 ions. So let's take 2 minutes, work it out now. You may need to use the algebraic method that we talked about just now. Okay? Okay, 1 minute more. Let's work on it and be careful, especially when there are negative numbers. You need to be careful with negative numbers, okay? Okay, are we good to start? If we are good to start, can you give me a thumbs up so I know you are good to start and you have finished all 3? Okay, wow, great. Seems like we can handle negative numbers like -1. Okay, to be really honest, you need to be careful whenever you have negative numbers, okay? Because many students, they start making careless mistakes, and as a result of that, they end up with the wrong answers. Okay, it's very exasperating to try your best and then you get the wrong answer because you just simply calculated wrongly. Okay, so let's start. So I hope you realize for such more complicated ions, you really need to write out working, okay, before you even start doing the problem. You should have written out such a working for the nitrate ion. So we are interested in nitrogen, the oxidation state of nitrogen in nitrate, NO3 minus. So we let the nitrogen oxidation state be X. Oxygen is always -2, so you have 3 times -2 because you have 3 oxygens. So X plus 3 times -2 equals -1. Why -1? Because the charge is -1. Okay, then you got to work it out slowly and make sure you don't make mistakes along the way, please. So you should have gotten X minus 6 is equals to -1. So now, carefully shifting terms around, you will get X is equals to +5. So of course, this gives us the answer +5. So the oxidation state of nitrogen is +5 in nitrate. Now at this juncture, most students are like, what? How can nitrogen be positive? Isn't it a non-metal? Yeah, but remember we said before, oxidation state is a concept that we invented for us to understand how redox works. We don't actually mean that nitrogen loses 5 electrons. It doesn't, right? But this is a convenient way to tell us that, oh, nitrogen is actually very highly oxidized. And why is it very highly oxidized? Because it's combined with oxygens. And we have proven it. The oxidation state of nitrogen is +5. Okay. Okay, let's go to the next one. Again, a familiar ion, right? Okay, I told you all to memorize this since term 2. Sulfate. SO4 2 minus. So what's the oxidation state of sulfur in sulfate? Okay, let's ask. Okay, Audric, what do you get for sulfur? The oxidation state of sulfur in sulfate.
+6.
+6. So again, if you do the maths properly, you should get +6. Okay, then we move to P. P is quite complicated. Wow, S2O8 2 minus. This one's one of my favorite examples. Wow, so complicated. Yeah. Okay, so these some of the ions formed by sulfur can be quite complicated. Okay, so it's not just sulfate. There are actually a lot of different ions of sulfur. Okay, so this is one of them. But nonetheless, the method to find out the oxidation state of sulfur is the same. Let it be X. But the complication here is, how many sulfurs do we actually have? It's S2O8, right? So X is for 1 sulfur. You got 2 sulfurs, so it's 2X. Oxygen is -2. Got 8 of it. 8 times minus 2. 2x plus 8 times minus 2 equals to the charge, minus 2. So this is where please make sure you do properly. Okay, so now that I have this equation, 2x minus 16 equals minus 2. So what is x? Okay, Jet, what's x?
+7.
Yeah, okay. So make sure you don't make careless mistake. Then you get the correct answer. Okay, so this is also the same principle that you will use for the remainder of the questions. You need to absolutely use this algebraic method when things get complicated. For example, nitrate is already quite complicated. So for the rest, the QRST, you really need to use this algebraic method to try to solve it slowly. And remember to be very careful whenever you are using negative numbers. Okay? So I hope this gives you an introduction how to assign oxidation states. We have assigned oxidation states just by using the 3 simple rules. The rules are only simple if you practice applying them. Okay, now you must be wondering, who invented these rules? How do we even know that these rules are correct? Well, like mentioned, we have invented this concept so that we can understand redox better. But are the rules totally groundless? Do we really have just random rules? Now, the rules are not random. How do we know that? So like just now I told you, oxygen is minus 2. If you think about it, actually oxygen, right, is group 6, right? Typically, it should gain 2 electrons, right? So typically, the ion it forms should be minus 2 in charge. And that's how we actually came up with that rule. Okay? So it's not totally groundless. There is still a basis behind it. Now, so what's all this hype about? Why do we even need to learn how to calculate oxidation states of particular elements inside a compound? Because oxidation states can be used to deduce whether something is oxidized or reduced. If the oxidation state of the element increases during the reaction, it's oxidized. Oxidation state increase, oxidize. If the oxidation state of the element decreases, it's reduced. That makes perfect sense. Oxidation state increase, oxidize. Oxidation state go down, reduced. Okay, so let's learn how to do this. So let's go to the next page. Next page is already filled in for you. Now, for redox, what's very important is to be able to write your answers in a particular format such that it's clear. So what I want you to do now is to pay attention to the format in which I've written my answer. So this is the typical question, right? By working out the oxidation states or considering the oxidation states, deduce which substance is reduced or oxidized. This is the typical question. They have told you that you must use oxidation states. You cannot go and use electrons, it doesn't work. Okay, you need to use what the exam question asks you to do. We will always specify. If we don't specify, then yes, okay, you have the freedom to choose, right? But that's rarely the case. Most of the time we will specify. So when you have a reaction like this, of course you must calculate oxidation state. Oxidation state of what? Well, of magnesium, of oxygen. These are the 2 elements present, right? So you should start calculating. Okay, magnesium is Mg. So at the start, is Mg. Mg at the start is not combined, it's an element. So the oxidation state of magnesium is 0 in Mg. But how about at the end? At the end, oh my goodness, okay, it has been combined with oxygen to form magnesium oxide. That's a compound. So this is no longer an element, right? MgO is now a compound. So now magnesium in MgO must be +2, because you know that oxygen is -2 in a compound. So magnesium went from 0 in Mg to +2 in MgO. So what can you say? 0 to +2, did the oxidation state increase or decrease? Well, it's quite obvious, right? 0 to +2 is an increase. So how do you write? Look at the answer. Mg is oxidized. Take note, this one is the formula of the reactant. Okay, so last lesson we already said this, reactant is on the left-hand side of the equation. You must be on the left-hand side of the equation, then you're the reactant. So Mg is oxidized as the oxidation state of magnesium. This one is called the name of the element. The element that you are counting for is magnesium now. The oxidation state of magnesium increase. Next part, very important. From 0 in Mg to +2 in MgO. You must write it like that. Don't just say increase from 0 to +2. No. You must tell me 0 where? 0 in Mg, +2 in MgO. Must specify. Okay? So this is always the format of the answer. Will not change. Do not deviate. Because when you deviate from this, you will miss out certain things. Okay? Can? So similarly, look at the bottom. I don't say oxygen is reduced. I say O2 is reduced. Why? I will use the formula. The formula tells me that it's a diatomic element. O2 is reduced as the oxidation state of oxygen. The name oxygen decreases from 0 in O2 to -2 in MgO. Again, specify. Okay. Many students end up losing marks because they didn't specify. Okay. Now I've given you the format of the answer like this. Is because I really want you to follow this. Okay, Redox is one of those few chapters where the markers tend to be a bit stricter about the way you phrase things. So you must adopt this phrasing. Okay, the actual calculating oxidation state, after some time, it will be easy, but it's the way you write your answers that matters as well. Okay, so now look at the format of the answers. Is there something that you don't understand? Okay, you want to ask now. Okay, no? Okay, so the format of the answers, please adopt this format. Okay, now of the 4 definitions, clearly the oxidation state definition, as well as the definition involving electrons, these are the 2 that are most commonly tested. So I would strongly advise you to learn the format of the answers very, very well. Okay, so really moving forward, you can just try the rest of the questions yourself. Okay, of course, you can also ask me to check later on once you have finished it. Okay, now these questions are not difficult because they typically only involve a few elements, and I've even worked out which elements should you calculate oxidation states for. Let's turn to this page. This is page 11. Can you go to part F? Okay, are we at part F on page 11? Okay, if you are, can you please give me a thumbs up so I know you're there already? Okay, thank you. Now, obviously, this is a more complicated equation, and this equation you will learn in the next chapter on metals. Okay, this is how we extract iron metal from iron trioxide. So basically, we take the iron trioxide and we react it with carbon monoxide. Okay, one of the reactions that occurs in this process that gives you iron metal and CO2. Okay, now quite clearly, right, there are 3 elements here. There's iron, there is carbon, and there's oxygen. There are 3 elements here inside the substances, right? So which elements do you count oxidation states for? That's the question that students always ask. I do not know where to start. Actually, you do. Actually, if you think back to when I taught you how to balance chemical equations, when Mr. So taught you how to balance chemical equations, I once said this. To balance an equation, you have to count the atoms, right? Make sure the atoms on both sides are the same number. Which atoms do you count first, though? In which order do you count? Does anyone recall this? Jamin, do you recall? Which atoms do you usually count first whenever you're balancing an equation?
Metals.
Yes. Okay. So similarly here, for oxidation state, it's the same concept. Which elements do you count the oxidation states for? Well, always start with the metal. Always count the oxidation state of the metals first. Obviously, the metal in this case is iron. So once you know that you need to do the iron first, that gives you a starting point, and that's why now let's calculate iron's oxidation state. Fe2O3. What is the oxidation state of iron in Fe2O3? Chiang, what's the oxidation state of iron in Fe2O3?
+3.
Okay, thank you. Okay, next, can I have Ming Heng? Can you tell me what's the oxidation state of iron here in Fe?
0.
0, because it's an element. So now you can write down, right? At first is from +3 in Fe2O3 to 0 in Fe. So metal done already. Iron is done, right? So what's next? What's next must be the non-metal. Same as balancing equation, but after the metal is done, you do the non-metal. By non-metal, I mean things like carbon, nitrogen, chlorine, all right? Do you do oxygen? No, oxygen and hydrogen should be last priority. So now if you look at this reaction, I need to count carbon. Okay, I don't count oxygen. I go and count carbon. Okay, so now let's do carbon. Let's ask people. Arun, what's the oxidation state of carbon in CO?
0.
0, carbon is 0. Is CO, it's a compound. Oxygen is -2, you know. So carbon is
+2.
yes. Okay, great. So carbon is +2 in CO. How about CO2? What's the oxidation state of carbon in CO2? Jiabao?
Is +4.
Yeah. Okay. So let's write it down now. From +2 in CO to +4 in CO2. Okay. Now there's a logic behind this. The reason why we don't count oxygen and hydrogen typically because their oxidation states don't change, right? You can see the oxygen is -2 throughout this equation. Okay. So you make sure you do the metal first, then the non-metal, then last priority. If the metal and non-metal done already, then you look at oxygen and hydrogen. Okay, so that's how you do a more complex equation where you have more elements. Okay, you just need to look at the metal and the non-metal first. Okay, so now writing out the answer, how would you present your answer? So firstly, let's deal with Fe2O3. Would you say that Fe2O3 is oxidized or is it reduced? Okay, let's ask someone. Andre, is Fe2O3 oxidized or reduced?
Fe2O3 is reduced.
Okay, so stay on the line first. Fe2O3 is reduced as, let's complete the sentence, the oxidation state of,
As the oxidation state of iron
okay,
in decreases from +3 to 0.
okay, are we missing something? +3
in Fe
2O3 to
to
0
Fe
in Fe. So
in
remember,
Fe.
this is important, don't leave this out. Okay, good. Now, important, most students will always forget is the oxidation state of iron. Not oxidation state of iron 3 oxide, not oxidation state of Fe2O3. It's the oxidation state of the element that you counted. You counted for the metal iron, right? Okay. So Fe2O3 is reduced because the oxidation state of iron decreases from +3 in Fe2O3 to 0 in Fe. Okay, so now the next one, of course, is CO, right? That's the other reactant. So obviously, when Fe2O3 is reduced, that means automatically CO is oxidized. Recall that is redox. In a redox reaction, if one reactant is reduced, the other one is oxidized. Okay, so let's complete the sentence. CO is oxidized as what? So let's try to complete this sentence. Jing Kang, how do we complete this sentence?
CO is oxidized as the oxidation state of carbon
As the
increases
oxidation
from-
state of carbon increases. Okay, from
+2 in CO to +4 in CO2.
okay, good. Okay, this is how you get 2 marks out of 2. Okay, so you have to learn this format. Okay, and you learn it, of course, through practicing it. So that's why there are many practice questions for you to practice. How do you work out oxidation states? Then how do you use that in your answer in this format to work out what's oxidized, what's reduced? Okay, and recall, whenever you want to count oxidation states, make sure you start with the metal first. Then you do the non-metals like carbon, nitrogen, chlorine, fluorine. The last priority is always oxygen and hydrogen. Okay. Ken? So with that, we've actually finished the final definition for redox, which is oxidation states. Okay. So how do you use increase or decrease in oxidation states of elements to work out whether something is oxidized or reduced? And with that, okay, I would like to move you back to page 2. So let's go back to page 2 and summarize what we have seen for redox thus far. Okay, let's go to page 2. On page 2, we started off by talking about the 3 types of chemical reactions. We have acid-base neutralization, we have precipitation. So these 2 types of reactions are not redox. Acid-base, not redox. Precipitation, not redox, okay? The one that is redox, of course, is everything else, okay? Ken? Now, we also went through 4 different definitions of redox, right? You can define it in terms of oxygen. So oxidation is the gain of oxygen. Reduction is the loss of oxygen. You can also define it in terms of hydrogen. So you notice for hydrogen, it's the opposite, right? Oxidation is the loss of hydrogen. Reduction is the gain of hydrogen. Okay, but we have said before, these 2 definitions are not very universally applied because there are many reactions which are redox that do not involve any oxygen or hydrogen. Okay, so usually we would like you to use definitions in terms of electrons, in terms of oxidation states. So we have learned yesterday that oxidation is loss of electron, reduction is gain of electron. Okay, Ken? And finally, today we have learned how to assign oxidation states, and we have learned how to use oxidation states to explain redox. Oxidation involves an increase in the oxidation state, whereas reduction is when the oxidation state decreases. Okay, and I think this is a good place for us to summarize, take stock of what we have learned, and more importantly, okay, go and practice the remainder of the questions yourself. You should be able to do everything until page 11 already. Okay, now tomorrow, okay, I do intend to finish up and finish redox. So tomorrow we will basically start with this page 12. We'll talk about disproportionation. Now, disproportionation, okay, is not directly part of your syllabus, but you do notice that it comes out very often in other school prelims as well as in the O levels. So you can see the disproportionation reaction actually came out twice, 2005, 2013. But that's not the only time that it came out, actually. It comes out relatively often, even though it's not part of the syllabus. Why? Because you are expected to apply your knowledge. Okay, so tomorrow we will start with disproportionation, this page. So you can read through this page before we start tomorrow. We also go on to oxidizing and reducing agents, which is the next part, okay, of the notes tomorrow. Okay, so we will stop here. If you have any questions, of course, you can stay back to ask. I would strongly recommend that you also practice the questions. And once you're done with the practice and you're unsure whether your answer is correct or not, you can tell me, then I'll just take a look at it. Okay, so I'll stop the recording here.